So I'm sure you've all heard by now that we're going to be doing e-learning for the rest of the school year. Be sure to look on Canvas for updates as to what the rest of the year should look like, and be in close communication with me if you have any questions. We're going to go ahead and jump into this new lesson here today. This will be one of two last lessons for Chapter 9, meaning today, Monday, we have one lesson, and then we will finish Chapter 9 on Wednesday. Alright, so look for more details on Friday during Wednesday's lesson. So here's the quadratic formula, and here's the best part about today's lesson is this method works every single time. And here's where it comes from. If I were to start off with ax squared plus bx plus c, and I were to complete the square, just hypothetically with all these values that I don't know, the formula you end up with is this. It's a big guy. But the good news is if you can follow order of operations, it shouldn't be too bad. I would say the main thing is identifying A, B, and C correctly so that you can then make sure you plug into the right spot. For instance, A is in 2 spots, B is in 2 spots, and then there is a part for C. So let's make sure we do that first. If we look at number 1, let's list A, B, and C first. So if it's written in standard form, p squared p, no p, then that's just going to be first one's A, which is 1. The second number is B, make sure that you include the negative, and the last number here is C. Alright, next step would be to plug everything in. Notice this is negative b, or the opposite of b, and b itself is negative, so we're going to need to plug in a negative and keep that other on the outside. Plus or minus goes in between two values. Alright. 2 easy simplifies you can do right off the bat is you can do negative 9 and 2 times 1. Okay, it's not really in order. Order of operations says that we should do parentheses first. I want you to treat this big square root like a set of parentheses. And when you get in there, the first thing I would do is the exponent. So negative 9 squared is 81. And then negative 4 times 1 is negative 4. Negative 4 times 8 is negative 32. And that cleans up to be 49. Lastly, square root of 49 is 7, and our answers become 9 plus 7 over 2, or 9 minus 7 over 2. So one answer is 1, and one answer is 8. It's a long formula. There are quicker ways to do this. That's why there's other methods available to you. The thing that works with this is it's an every time kind of thing. There's nothing that's ever going to be in the way of you solving this problem with the quadratic formula. Number 2, we're going to start off the same way. Write your formula, write out A, B, and C. It's important that you do this every time so that you can actually see what you're plugging in. So while you might be doing a Pearson assignment, it is better for you if you write this on paper, work it out, and then put the answer that you get into Pearson. So A, again, first guy, 1. B is the second guy. C is 12. So I get negative 7. 7 squared. 1, 12. And then 2 times 1 again. Okay. The 2 easy ones are negative 7. And the bottom becomes 2. Inside your square root, you have 7 squared, which is 49, minus 4 times 1, which is 4, and then that times 12, 48. So this cleans up to be the square root of 1. Alright, well remember the square root of 1 is itself. So our two problems are negative 7 plus 1 over 2, negative 7 minus 1 over 2. Just remember how to do your signed operations. If the signs are the same, you add and keep the sign. If they're different, like negative 7 plus 1, you subtract. 7 minus 1 is 6. Keep the sign of the bigger number. So your two answers here are negative 3 and negative 4. This is an interesting problem where all the A's, B's, and C's are 11, except for B is negative 11. So just make sure you make that distinction. So we're going to say negative 11 plus or minus negative 11 squared minus 4 times 11 times 11, 2 times 11 on bottom. Positive 11, that's the negative of a negative, and then 2 times 11 is 22. First time we've seen something other than 1 in the bottom. The inside, let me make this clear that anytime you square any number, it should be a positive. So if I square 120 or 11, I get 121, and it's the same as if I do negative 11 because it's a negative times a negative. So this is still 121, and then these two are going to make 121 times 4, so that'll be minus 484. So when we subtract here, we're going to get a negative number in here of negative 363. And here's a telltale sign. How do I tell if there's no solution? Anytime you are square rooting a single digit and that single digit is a negative. And since that's the case here, we would say no solution. Our last example today is a little different. You'll notice that we have values on the wrong side, meaning this is not equal to 0. So I need to add 6, and I'm going to get x squared minus 49. Okay, so when you do A, B, and C, then A is 1. B is the value attached to x, and there's not 1. So we're going to put 0 for B, and then C is negative 49. Go ahead and pause the video and see if you can solve it from here, and then hit play when you're finished. Alright, let's see what you got. Negative B, that's just negative 0. 0 squared minus 4 times 1 times negative 49 over 2 times 1. So that's 0. If you ever have 0 in front of a plus or minus, just leave the plus or minus. And then in the bottom here we have 2. 0 squared is 0, but you got a negative times a negative, which is a positive, and that's going to be 196. Just clean that up with plus or minus 196. Alright, now this is where you take the square root, but plus or minus and the 2 are not part of that. You type into your calculator the square root of 196, or put it into Google or whatever you want, and you should get 14. So my two problems are 14 over 2 and negative 14 over 2. So my answers are 7 and negative 7. Okay, go ahead and try the quadratic formula assignment on Pearson. Make sure you're going through the calendar and clicking on the links. If you have any questions, let me know.